Kia ora year 11, 12 and 13. Here's another question from today's calculus exam. This is one of the ones from complex numbers. So this is one where we're told that we have to figure out what the coefficients are in a complex number. So we have to find the values of x and y, given that both of those are real, and this is true. So at the outset, I'm going to say I'm going to do this problem in two different ways. I'm sure there are many more ways to do it, but the first way is the way that I saw straight away, and then the second way is a way that I think some of you might have tried, and I just want to show you that you will get there with that second way, but it's going to be a wee bit messy. And I'm sure someone's going to let me know if there's yet another way that I have missed. Right, so this is the equation that we're starting out with. And as soon as I see complex numbers with stuff in the denominator, I know that I'm going to end up rationalizing that denominator by multiplying by the conjugate of the complex number. So I'm looking at this one and also at this one. But the first thing that I did here is that I took this and added it to both sides, and that gave me the following equation just before I did anything. So I've got 1 minus 2i plus 1 over 1 plus I. And straight away, I know that I'm going to multiply this by 1 minus I over 1 minus I. So we might as well set that up. And now I'm going to clean up that right-hand side. So just let the 1 minus 2i sit there. And here we've got 1 minus I in the numerator. And down here, we get 1 minus I squared, so 1 plus 1. So you can see this problem has collapsed already into something extremely doable, except that I just mark that up. Let's just look at this. So I've got a denominator here of 2. I'm going to make a single term fraction thingy. So I've got 2 times 1 minus 2i plus 1 minus I. So that gives me 1 over our mysterious number is equal to 2 plus 1, so 3, minus 4i minus I, so 3 minus 5i over 2. Now, if 1 over the number is equal to this, then if I take the reciprocal of each side, we get x plus iy is equal to 2 over 3 minus 5i, and I need to multiply by the conjugate again. And we're basically done. Don't stop watching because I want to show you the other way, or at least the start of it. So here in the denominator, I get 9 minus 25i squared, so 9 plus 25. And in the numerator, I get 6 plus 10i. So x plus iy is equal to 3 over 17 plus 5 over 17i, giving me x is equal to 3/17 and y is equal to 5/17. Okay, so brilliant if you did it that way. As I said, I'm sure there's a better way, but let's now look at the way that some of you might have done, which is to look at that equation and start combining the stuff here. And you get into a little bit more mess, but you do end up coming out of the mess. So let's see how that works. Right, well, we've got 1 over x plus iy minus 1 over 1 plus I is equal to 1 minus 2i. Now, if I go ahead and combine the left-hand side into a single fraction, what do we get? Well, we get 1 plus I minus x minus iy equals 1 minus 2i. So cleaning up the numerator, I get 1 minus x for the real part plus I times 1 minus y is equal to 1 minus 2i times 1 plus I times x plus iy. Right, so let's work on this bit first. So on the right hand side we've got 1 plus 2 from here minus 2i plus I. So that gives me minus I times x plus iy. So 3 minus I times x plus iy. And over here, popping this back in, we haven't done anything. So we're down to here. So what we're going to do is continue to fix up the right-hand side and then we're going to equate the real part and we're going to equate the imaginary part. So the real part here is going to be 3x minus yi squared, so plus y, plus I times 3y minus x. Right, so what does that give me? Well, I've got two equations and two unknowns. So 1 minus x is equal to 3x plus y, and 1 minus y is equal to 3y minus x. Over here, I'm going slowly because I didn't do it this way, but I think you can do it this way. So you get 1 equals 4x plus y, and here, what have we got here? Well, we've got 4y, whoops, what am I doing? 4y minus x equals 1. So I can do this in a couple of ways. I can do substitution here. They both equal 1. So 4x plus y equals 4y minus x. That gives me 5x is equal to 3y, and you can probably start to see the pattern with there's no 17 yet, but we've got a 3 and we've got a 5. So 5x is equal to 3y. So x is equal to 3/5 y. So take that and substitute that into either of these. You could do this with elimination as well, right? So we've got 4y minus 3/5 y is equal to 1, giving me 17/5 y is equal to 1, or y is equal to 5 on 17, and then x is equal to 3/5 of 5 on 17, which equals 3/17. But you can see that that took me way, way, way longer. Okay, so the chances of you mucking that up under time pressure are quite high. So it's just another example, especially if you're watching this and you're doing level 3 next year and you haven't just sat it today, just have a good look at the question before you dive in. All right, so there's that one done. That's probably all I'm going to do tonight. Leave me a comment if there are any other particular questions you'd like to have a look at.